After this lesson, students will be able to solve two-step and multi-step equations by using inverse operations to isolate the variable. Try these 4 questions for the do now on your own, so pause the movie and resume when you're ready. Number 1, we have a minus next to a negative, which gives us x plus 6, which is equal to negative 4. And we take the inverse of adding 6, which would be subtracting 6 from both sides of the equal sign. The positive 6 and negative 6 cancel out, which leaves us with x on the left side, and negative 4 minus 6 is the same sign, so we add and keep the negative sign. So x equals negative 10. Number 2, we take the absolute value of negative 7, which is positive 7, plus x equals 13. Now 7 is positive, so we would subtract 7 from both sides in order to cancel it out. 7 minus 7 is 0, so we're left with positive x, or just x, which equals 13 minus 7, or 6. Number 3, we begin by combining like terms. 6 minus 2 gives us 4, minus x equals 10. Now the 4 is positive, so we're going to subtract 4 from both sides of the equal sign. Don't let this minus sign here confuse you. We're focused on trying to isolate our x. So in order to cancel out the 4, which is positive, we have to do the inverse to both sides. Positive 4 and negative 4 give us 0, so those cancel. We're left with negative x, which equals 10 minus 4, or 6. You can think of negative x as being negative 1 times x. So we now divide both sides by negative 1, and we're left with x equals negative 6. Number 4, we begin by combining like terms. 9 plus 15 gives us 24, so we have x plus 24 equals 30 minus 12, which is 18. We're adding 24 to x, so the inverse would be to subtract 24, which we do to both sides of the equal sign. And now we're left with x equals 18 minus 24. These are different signs, so we subtract and take the sign of the higher number. So we have that x equals negative 6. Now in order to solve multi-step equations, we begin by simplifying one or both sides of the equation, and then we use inverse operations to isolate the variable. Now the key here is that we use the inverse or opposite operation in the reverse order of PEMDAS. You can think of us as being almost like investigators, where we're retracing our steps in order to figure out what the variable is. By retracing our steps, we have to do the order of operations backwards. So we would begin with addition and subtraction, and then move on to multiplication and division, and then the exponents, and then the parentheses. For those of you that like to have a step-by-step process, step 1 would be to start simplifying by distributing whatever we have to distribute in order to get rid of the parentheses. Step 2, we combine like terms on either side. Step 3 would be to undo addition or subtraction. Step 4 would be to undo multiplication or division, etc. So for example, if we have 6x plus 11 equals 53, right now we have multiplication and addition occurring to our x. So the question becomes, which do I get rid of first, the plus 11 or the times 6? Well, since we're being investigators and retracing our steps, we go in the reverse order of order of operations. So while we would normally add or subtract last, that's what we're going to start with. So the inverse of adding 11 would be to subtract 11 from both sides. and we're left with 6x equals 42. Now we're down to just one step, which would be to get rid of the multiplication, so we divide both sides by 6, and we're left with x equals 7. Now, as always, it's a good idea to check our answers, so we can plug in 7 for x and see if this works. 6 times 7 plus 11 equals 53. 6 times 7 is 42. And when we add 11, we do get 53. And therefore, x does equal 7. Now for number 2. We have w divided by 9 minus 22 equals 14. Our first step is to undo addition or subtraction, so we're going to add 22 to both sides. And we're left with w divided by 9 equals 36. Now, since we're dividing w by 9, the inverse would be to multiply both sides by 9. This cancels out the 9, since it would be like 9 over 1, and then we would cross-reduce. And we get that w equals 36 times 9. Or 324. And now we can check our work. When we plug in 324 for w, let's see if we get the right answer of 14. So 324 divided by 9. And we have 36 minus 22 equals 14. And 14 does equal 14, so w is equal to 324. Now you try these 4 questions, so pause the movie and resume when you're ready. Number 1, we start by adding 16 to both sides, and we get that 4y equals 32. Divide both sides by 4. Y equals 8. And we should plug in 8 for y to double check our work. Now number 2, we have division and addition, so I'm going to start by subtracting 4 from both sides. T divided by 17 equals 4. The inverse would be to multiply by 17. And we get that t equals 68. Number 3, we subtract 11 from both sides. Divide both sides by 7. And we get that b equals 21. And number 4, we add 3 to both sides. So c divided by 18 equals 23. And then we multiply both sides by 18. And we get that c equals 414. Now try these with fractions. Don't let the fractions scare you. Pause the movie and resume when you're ready. So, in this question, we have 7 plus 2/3 x equals -1. We're multiplying x by 2/3, and we're adding positive 7. So we begin by getting rid of whatever we're adding or subtracting. which would be the positive 7. So we subtract 7 from both sides first. Then we're left with 2/3 x equals negative 8. Now we're multiplying 2/3 times x. The inverse would be to divide by 2/3 or to multiply both sides by the reciprocal, 3/2. The 3's cross-reduce and give 1, the 2's cross-reduce and give 1, so we're left with just x. On the right, we have negative 8 over 1 times 3/2. We can cross-reduce the 2 and the negative 8, which gives us negative 4 and 1. Negative 4 times 3 is negative 12 over 1, which gives us negative 12. Number 6. We have 18 minus 1/4 x, which equals 22. We're multiplying x by negative 1/4, and we're actually adding 18. So in order to get rid of the 18, we would subtract 18 from both sides, which gives us 4 equals negative 1/4 x. Now since we're multiplying by a fraction, the inverse is dividing by the fraction or multiplying by its reciprocal. I'm going to begin by using my symmetric property to switch the sides just so it's easier for me to see. And now I'm going to multiply both sides by negative 4 over 1, which is the reciprocal of negative 1/4. And these all cancel. And we're left with x equals negative 16. Now, if we're ever unsure of our answer, you can always plug in what you get for the variable and see if it works. So to check this, we would say 22 equals 18 minus 1/4 times negative 16, which is like negative 16 over 1. Now I can start by multiplying or cross-reducing. So I've got my 4, which could be like 1, and my negative 16, which becomes negative 4. Now when I multiply negative 1 times negative 4, I get positive 4 over 1, or positive 4. So 22 equals 22, which works. Now for some real-world problem solving. A music store sells a copy of a deluxe electric guitar for $295. This is $30 more than 1/3 the cost of the deluxe electric guitar it is modeled after. What is the cost of the deluxe electric guitar? Well, we're going to let x equal the cost of the deluxe electric guitar. Some keywords were more than and 1/3 the cost of the deluxe electric guitar. So, since it's $30 more than 1/3 x, that would be like saying 1/3 x plus 30. And that is the copy of the deluxe electric guitar, which is $295. So to recap, we decided that x equals our unknown in this problem, which is the cost of the deluxe electric guitar. Here we see it says the cost of the deluxe electric guitar. So all those words, really, we are now referring to as x. $30 more than 1/3 x More than is when you switch around the order. So we have 1/3 x plus 30. And that equals our $295, the cost of the copy of the deluxe electric guitar. Now that we have this equation, we can solve for x in order to find the cost of the deluxe electric guitar. So we subtract 30 from both sides, since we start by undoing our addition and subtraction. And then we multiply by the reciprocal, which is 3. And we're left with x equals 265 times 3, or 795. So, the cost of the deluxe electric guitar is $795. Now you try this problem. Pause the movie and resume when you're ready. Suppose your high school's baseball team scored 5 runs in Saturday's game. This was 4 more than half the runs scored by the opposing team. How many runs did the opposing team score? Well, we don't know how many runs the opposing team scored, so that's going to be our x. The number of runs the opposing team scored. Five is 4 more than half the runs scored by the opposing team, which we said was x. So 4 more than half of x is 1/2 x plus 4, and that is 5. So now I can solve for x in order to find the number of runs the opposing team scored. I subtract 4 from both sides to get 1/2 x equals 1, and then multiply by the reciprocal. So we have that x equals 2. The opposing team scored 2 runs. Pause the movie and try this question. Resume when you're ready. In a catalog, tulips cost 75 cents each, and shipping costs are $3. Write a rule that describes the amount spent as the function of the number of bulbs ordered. Then, determine the greatest number of bulbs you can order for $14. So we don't know how many bulbs are ordered, so that's going to be our x. So x is the number of tulip bulbs ordered. The cost is 75 cents per tulip bulb plus the shipping costs, which are $3, regardless of how many bulbs you purchase. In other words, we're going to take 75 cents and multiply that by the number of bulbs you order plus the one-time charge of $3 for shipping. This describes a rule that explains how much money you would spend on a tulip bulb order. Now, we're supposed to determine the greatest number of bulbs you can order for $14. So we're going to say that our order equals $14 and figure out how many bulbs we can get. So we're going to subtract 3 from both sides, and we get 0.75x equals 11. Now I can take 0.75 and change that to 3/4 to make this a little bit easier. and multiply by the reciprocal of 4/3. I can't cross reduce, so I have that x equals 44/3. And I'm going to take Nancy, the numerator, and put her in the house with doggy denominator outside of the house. 3 goes into 4 one time. 3 goes into 14 4 times, with a remainder of 2. So x equals 14 2/3. Now we're supposed to determine the greatest number of bulbs we can order for $14. Since we're not going to order 2/3 of a bulb, the greatest number of bulbs we could order is 14 bulbs. So you can order 14 bulbs for $14. Go ahead and try this question. Pause the movie and resume when you're ready. A gardener is planning a rectangular garden area in a community garden. His garden will be next to an existing 12-foot fence. The gardener has a total of 44 feet of fencing to build the other 3 sides of the garden. How long will the garden be if the width is 12 feet? Well, it was nice that this question already provided us with a picture. Sometimes you won't be provided with a picture, and in a question like this, it's always a good idea to draw one for yourself. We see that this side of the rectangle is already an existing fence. And we know that it's 12 feet, so the other side needs to be 12 feet. Now he has a total of 44 feet of fencing to build these 3 sides. Since it's a rectangle, the other 2 sides need to be the same length of x. So we know that x plus 12 can equal up to 44 feet of fencing. And in order to make the biggest garden possible, he'll use all 44 feet. X plus x is 2x. And now we can go ahead and isolate our x by subtracting 12 from both sides and dividing by 2. So we found that x equals 16. So the garden will be 16 feet long. Now sometimes we're going to have to simplify first. So recall on our beginning of our lesson with the slide where we had our steps that we begin by using distributive property or combining like terms in order to simplify first, and then we get rid of adding and subtracting, and then multiplying and dividing. So far the questions that we've been doing, we've been able to start by getting rid of the addition or subtraction and moving on to the multiplication and division, which is really steps 3 and 4. Now number 1, you'll notice that we have 2 x's. Since those are like terms, we're going to begin by combining the like terms and get 2x plus 15 equals 41. And now I can move on to steps 3 and 4 by subtracting 15 from both sides and dividing by 2. Number 2, we have distributive property because we have a factor, 5, that is being multiplied by a quantity, x plus 7. So we're multiplying 5 by our x and our positive 7 to get 5x plus 35, which equals 90. And then we can subtract 35 from both sides to get that 5x equals 55. And then divide both sides by 5 which gives us x equals 11. Now another option here, just to show you, and then you can choose which way you like better. Since we are taking 5 and multiplying it by a quantity, instead of distributing, we could have divided both sides by 5, the inverse of multiplying by 5. That would cancel out the 5's here. And now that we have just x plus 7, we don't need them in parentheses anymore, since that's the only operation occurring. Now x plus 7 would equal 90 divided by 5. I can go ahead and do 90 divided by 5. Which gives us 18. And then subtract 7 from both sides, which gives x equals 11. The same answer we got after distributing. So you have a choice to either distribute the 5 and then go from there, or divide both sides by 5 and go from there. Now number 3. We begin by distributing our negative 4 to negative 3x and positive 2. We just bring down our 6x. Negative 4 times negative 3x is positive 12x. Negative 4 times positive 2 is negative 8, and that equals 10. Now I can combine like terms. 6x plus 12x is 18x, minus 8 equals 10. Add 8 to both sides. So we get that 18x equals 18. And when we divide both sides by 18, we get that x equals 1. Now number 4, again, we have a choice. If we want to distribute the 3/4 to the x plus 6, or if we want to divide both sides by 3/4. In other words, multiply both sides by 4/3. I'm going to multiply both sides by 4/3. These cancel, so we're left with x plus 6, and I can also cross-reduce the 12 and 3 to get 1 and 4, and that gives us 16. Now I can subtract 6 from both sides and get that x equals 10. Pause the movie to try these 4 questions on your own and resume when you're ready. Number 1, we have to combine like terms. So 10x minus 3x is 7x, and 20 plus 1 is 21. And now we can divide both sides by 7 in order to get x equals 3. Number 2, we can either distribute the 2 and go from there, or we can divide both sides by 2, which is what I'm going to do. This leaves us with x minus 4 equals 1, and then we can, oops, I'm getting ahead of myself here, and then we can add 4 to both sides, so we get that x equals 5. Number 3, we can distribute 1/3, or start by multiplying both sides by the reciprocal. And we're left with x plus 6 equals 3. Subtract 6 from both sides, and we get that x equals negative 3. And finally, number 4, I'm going to divide both sides by negative 2. So we get negative 7 equals 4x plus 5. I get rid of the addition of 5 by subtracting 5 from both sides, which gives us negative 12 equals 4x. Divide both sides by 4, and we get that negative 3 equals x, or x equals -3. Now try these questions, pause the movie, and resume when you're ready. Number 5, we could distribute -2 or divide both sides by -2. b minus 4 equals -6, and then we can add 4 to both sides to get that b equals -2. Number 6, I see more than one z, so I'm going to start by combining like terms. -3z and -2z, because this positive sign goes away, gives us -5z. Plus 8 equals -12. Subtract 8 from both sides, and we get that -5z equals -20. Divide by -5, and we find that z equals +4. Now for number 7. We have a couple of options here. Notice how we do have two x's, so we are going to have to combine like terms. Now, since these are written like fractions with unlike denominators, we can try to get a common denominator. So, for example, our least common denominator would be 6. So I can multiply by 2, which means I'd have to multiply our numerator by 2 as well. And over here we'd multiply by 3, so I'd multiply the numerator by 3 as well. 2x times 2 is 4x over 6, plus x times 3, or 3x over 6, which equals 7. Now that we have a common denominator, we keep our denominator when adding fractions, and we add up our numerators. 4x plus 3x is 7x. Now I can get rid of the denominator by multiplying both sides by 6. And we get that 7x equals 42. And now we divide both sides by 7 to get x equals 6. Now number 8 involves a lot of decimals. We could just deal with the decimals, or we can try multiplying every single term by a certain factor in order to get rid of those decimals. Notice that if we were to multiply by 100, that would get rid of all of these decimals. 0.5 times 100 would be 50, A, plus 8.75 times 100, which would be 875, equals 13.25 times 100, which would give us 1,325. Essentially, we're multiplying both sides by 100 because in an equation, we're allowed to do whatever we want as long as we do it to both sides of the equal sign. Now, I don't have to worry about the decimal points anymore, which is kind of nice. So I can focus on isolating my A. I subtract 875 from both sides. And we get 450. Divide both sides by 50. And we get that A equals 90. In summary, use the distributive property to remove parentheses on each side, combine like terms on each side, undo addition or subtraction, undo multiplication or division, and continue going in the reverse order of operations until you've isolated your variable. Don't forget that it's always a good idea to substitute whatever answer you get for your variable into the original problem to see if your problem is in fact true.